Hi everyone. Today I wanted to go over organizing the structure of the code and just so we can make things a lot easier to read. Like every time we open up an example, for example, here, let me close this. For example, when you go to the ArduCam library or to the examples, say we want to open up the ArduCam Mini Capture 2SD. When you look at it, you just see a bunch of text, and it's a little overwhelming because it's hard to understand like the structure of this, like what's going on, you know. So whenever you have a new file, um, whenever you open up a new file, you get this text right here, and as you know, inside the Vortex setup, this is where you just set up things. Like if you set a specific pin as an input or an output, or there's many things you can do in the setup, and this only runs once. And then you have this void loop. So if you remember, anything you put in here is just constantly going to run. As soon as you power on the Arduino, it's going to start from line 1 and scan down, and it's going to see the setup. This is just to organize some setup code. It's going to scan it once, but once it gets to this void loop, it's just going to run whatever is inside constantly. It's going to just keep going in circles, and it's always going to be scanning things. Now, that's a very basic structure. In reality, when things get a little more advanced, or you want to do a lot more, you're going to start incorporating functions. So, for example, let's look at this. Obviously, this Capture 2SD, this is when you take a picture with the ArduCam, and then it stores that picture inside an SD card. As you can see, it's very different from this, right? They don't start off with the Vortex setup. They start off by including a bunch of files that they need, which makes sense. And so I know it's going to take some time for you guys to learn C++, and that's totally okay. We're going to start off with the very basics, and I'm just going to, that's going to be one of the biggest focuses in the future, and we're just going to practice C++ code all the time for you guys to be able to understand all this. Right now, I don't expect you guys to, and that's totally okay. So don't get too stressed out. Just try to think about things conceptually. And if you can, if there's an app or something, or a website where you can practice C++, that would help you a lot. I would recommend more to just do small projects with Arduino, or big projects, whatever you want, because for me, that's really how I learned Arduino and coding in general, and it's really fun, and it's really awesome. Anyway, so as you can see in this example that the ArduCam people provided, they include 1, 2, 3, 4, 5 different files, and it seems that 3 of these files are from Arduino themselves. So if you remember, the wire .h file is for I2C. That's what allows us to use all their shortcuts and their quick functions to make I2C communication really simple. And they also have a spy.h file, which is just for the SPI communication protocol, where you could adjust the data rates at which data is transferred, and they make that all really simple with functions. So we have to include these so we can use those functions. And then they have an sd.h file, and that's just so we can use functions again that they've written, so we can use an SD card, and they just facilitate the process for that stuff. Now, there's 2 other files, the arducam.h file and then the memory.h file, and that's actually, ArduCam wrote those. And obviously, in order to make this whole code work, they're referencing these 5 files, which have a lot of functions in them and definitions that they get tedious in there, but in this code, we can simply call something like ArduCam is a function inside one of these. I think it's in the arducam.h file, and basically, actually, we shouldn't get into this right away, but what you just want to know is that they're using these 5 files, and referencing specific things from them and bringing them up here. So if you ever want to look inside these files, so let's start off with our Arduino files, the wire, SPI, and SD.h files. I know that the wire and SPI files are internal to the IDE. They're just in there. I need to look up exactly how to find them. I'm sure you can find them online, but I know that the SD file is external and you can just find that in your folder. So if you go to your folders, so there's, this is a quick lecture I made about changing the IDE to dark theme. I don't know if I told you already, but I made a quick video about how to change the look of your IDE to dark theme. That's really cool. So if you want to have this look, feel free to watch that. It should be posted next to this lecture. Anyway, so if you go to your C drive, under program x86 files, I think this is for 64-bit applications, and this is for 32-bit applications. They tend to put the 64-bit applications here. So if you, my Arduino folder is in here, and then in here they have the application itself, the .execute file that opens up the IDE, and then they have this libraries folder, and inside here they have some libraries that they wrote. Here's the SD one. It's referencing the sd.h file, so that's actually in here somewhere. It's usually under source, and here it is. So if you want to look what's inside of this sd.h file, you can just click on it and then see they've written, oh, it's not too much, but still complicated code. They write classes. That's something that's used a lot in C++ classes. And we'll look into those in the future. You won't really, the Arduino IDE itself doesn't use classes. You don't tend to write classes unless you make a .h file or something. So don't stress too much about that right now. And by the way, I'm using Sublime. I know everything I have is dark theme. If you download this Sublime text.3, it's just a text editor. It's nothing too fancy. It just allows you to display things with this, and it color codes everything. And what's cool is, like, every time I open up a file, I say, oh, this is a C++ file. So you go down here and you choose the language. You can use C, you can use Python, you can do anything, and you just click on the type of file that it is, C++, and then it automatically recognizes the structure of things and then color codes things. And it's really cool. There's a lot of benefits to this, but I'm not going to get into that right now. This is just how I like to see files. Okay, so back to this. So these are Arduino's files. This one and this one are Arducan's files. And if you want to look into those, I mean, at some point you had to edit this file, the memory saver.h file, because this file lets the code know that we're using the OV5642 mini 5-megapixel camera. And if you remember, you have to go find it. Where did I put it? I think I put it, if I go to documents, a lot of stuff, Arduino, I forgot exactly where I put it. I know okay. Okay, if you go here to the Arducam, it's going to be here. So here's a memory.h file. And remember, when you open this file, again, it's using Sublime, you have to let it know that you're using, this is for, sorry, this is for the camera. What type of camera you're using, not specific Duet. If you're using the Duet, you have to use this bit rotation fixed. If you're just using a different Arduino, you just use this one, I'm pretty sure. Yeah, so here, this is an example. So we just, you know, if we're using a different camera, we would do this. Oh, this is for the original. If you're using any Arduino, you would uncomment that one. because we have the mini. Actually, I don't know what the difference is between this one and this one. Okay, sorry, ignore that. All I know is that for the Arduino Due to work with the camera right now, we have to use this one. I'm pretty sure the other ones are, if you're not using the Arduino Due, I think you do this. You uncomment that one and this one. Yeah. But since we're using the Due, we have to use the bit rotation fixed. And then you just save the file. And then now, whenever this example, for example, runs, it knows that it's going to use this file, and this file says that, oh, we're using this specific camera, the OV5642. And in the code, you can tell that it says if, by the way, this exclamation point means not. So if if none of these are defined in the memory.h file, it's going to give you an error and say, please select the hardware platform and camera module in the memory.h file. So this only works if you're using the OV5642 camera. If you're using some different camera, like if you're using 3, 4, oh, it looks like this one can take any camera. Yeah, but if you're just using something that's not like an OV, it's immediately going to give you an error. Or yeah, if you just happen to leave them all commented, it's not going to detect anything, and it's going to say, please select the hardware platform. So that's why whenever you select this, by the way, you have to click save. It's going to be like, oh, it's using the, oh, there it is. It's using this line. Therefore, it's going to not give you the error. Remember, because if none of these are chosen, the not comes from the exclamation point, give this error. Otherwise, you know, end if, it's just going to continue. So this thing is one thing together. Okay, and then you define the CS pin for the SD card, and then you also define the CS pin for the ArduCam. I don't know why they did this define. You could honestly just do the same thing and say const int, and then say you're making this variable, and then that should work too. So you can verify if something works by pressing verify. This compiles your code and sees if it can read it or not. So let's see if it reads that. Yep, so it finished compiling. That means there was no error. Say if I forgot like a semicolon or something and you click verify, it's gonna yell at you. It's gonna say, oh, we expected something before this line, so right here. So you just do that. But for some reason they had it as they had it like this. So I'm just gonna leave it like that. But just so you know, sometimes you can define variables just by putting hashtag define. But it's useful to be able to, you know, give it a specific data type. For example, we're going to make this an integer, and they're keeping it constant, so it shouldn't change. I don't know why they're doing that, but don't get stressed. And then the next line says, okay, if this camera is defined, we're going to set up the ArduCam. By the way, this comes from the arducam.h file. If you go to it, here, it's going to be in here. So we just went to the memory.h file. If you find the arducam.h file, it's right here. And then this is just a ton of text that we don't really need to look at. But it seems like this ArduCam specifically, if you go to Sublime, actually, let me show you. So right now, we're here in the ArduCam folder. If we go to examples, go to Meany, and then go to the same example. This would open up the Arduino IDE file, but if we open it in Sublime, open with Sublime Text, and then right now it doesn't recognize the language, so we're gonna put, it thinks it's plain text, but it's not, it's C++. Okay, so now it makes everything all pretty. If you look, Sublime is cool because look, you can highlight the word, put your cursor over it, and then it tells you, oh, this is defined in the .h file. Remember, this is right now, this is just the, ooh, sorry, I have so many things opened up here. Okay, don't make that. Okay, so this is all we care about. The arducam.h file, the memory.h file, and then the SD one if we want, but right now we're not talking about that. So I have the example open in Sublime. What's cool about Sublime is that if you go over some specific function like arducam.h, it's going to say, oh, this is actually defined in the arducam.h file in line 644. So we can either go to here and go to 644 and be like, oh, this is where it's defined as a class. You can see exactly what goes on inside. Again, this stuff is we don't have to know what's going on right here because that's the professional people right now. They did some stuff that we won't know about for now. So you could either do that or you can easily just click and then it takes you immediately there. And then you can see exactly what they did. And again, this is all advanced, pretty advanced C++ code. What's standard once you get used to it. But we're going to learn a lot about C++ in the future. Don't worry, we're going to put a big emphasis on learning C++ because it's used so many places. If you learned any other language like Python, it's going to help a lot with this too. So learning languages is great. So back to this. This is just, as you can tell, it's all set up. So right now it's saying, okay, if it's defined as this, that we're using this camera, and again, this probably comes from the memory.h file, you know, do this. Elif means else if, like otherwise, if that's not the case, if this one's defined instead, do this. Otherwise, it must be basically the OV5642. So in our case, we defined the camera as an OV5642. And yeah, since it wasn't either of these, it's saying else it has to be this one, OV5642. And then it sets what the SPI, the chip select pin is. I know this stuff is complicated right now, so don't focus too much. I'm just showing you that in general, when you start off code, it's all set up. And then right after that, you can see that they start with a function. And this is what's confusing. Okay, let me just go back to the IDE. This is what you should be looking at. And oops, okay, let me correct this again real quick. So we're back to the IDE. Oh, what did I do? Oh, we don't need that. Okay. Okay, so we're back to the IDE. And so we just looked over this, and then it starts with a void function, the mycam save to SD file. And that's confusing because if you look at a normal sketch, like it should go to the setup function, not this. But whenever you want to make your own functions in Arduino, you're actually going to set them up here. You're going to set them up here. Say void any other function I want to use. Okay, yeah, that was unnecessarily long. Don't do that. But I'm just trying to show you how the structure tends to work. And then, you know, you would do whatever. And again, functions are to make things simple so you don't have to write a ton of code in the void loop. So the reason, I don't think, I tried once, if you put it at the bottom under here, oops, it's actually not gonna read it because it's gonna start from scanning up, down, it's gonna go through this, it's gonna go to, okay, you have this set up here. And then once it goes to the void loop, it's just gonna go continuously. But I think they updated to change that. I don't know, it might be able to detect that there's another function here. It should, but anyway, what's standard is that you actually put your functions up here. And that's exactly what ArduCam did with this memory card example. They just put a function above the setup function. And as you can see, this function is long. Let's start separating things. So remember, that's a comment. So I'm just gonna put a large line just so I can see things better. So I'm gonna copy this so I can, okay. So here's a function, let's figure out where it ends. So they're doing a lot of, okay, it ends here. So I'm just gonna, just so I can visually see where things are. So as you can tell, this is one huge function that's just all this. And then they get to the void setup. I know I said we set things up here. So right here, we tend to set up things like files and, you know, some variables. And the void setup function, we just tend to set up other things like it's kind of up to you. You're really, you know, we could actually put all this up here, but just for organization, you tend to define your files up here, and then you set your pins down here, and you start the SPI, and we're going to talk a lot about this stuff in the future. Honestly, I haven't looked at every single line yet to understand what's going on, but I know we can figure it out. So remember, this is one big function. And what it does, as you can tell by the name of the function, myCamSave2SD file, this is probably responsible for taking a picture. And you must wonder why, like, when is this called? And that's actually going to be called in the loop, in the void loop. If you remember, we tend to put things in here that we want to execute for a while, or just constantly, repeatedly. And so let's find the void loop function. Oh wow, it's over here. Okay, so all this is void setup from here to here. This is all void setup. So all this runs once. So this is just code that you need to run once. And you can see that this is just letting, like, this is code that runs once to check that, okay, the SPI interface is working, the SD card is detected. If we're using, okay, so if we're using this camera, do all this to find the camera. ELIF means otherwise. If that's not the case, and we instead are using this camera, do all this, detect this camera. By the way, while one, it just keeps running consistently until you break away from it. So it's smart things. Right now, we're not gonna focus on this too much, but I'm just telling you conceptually what's going on. So if this camera was detected instead, do this to find it and detect it and configure it. Otherwise, it's basically saying you must be using the OV5642 camera because there's no other options left. That's why it doesn't say define OV5642, because it just assumes that, okay, you're not using the two options. There's 3 options in total. You already went through 2. If this wasn't detected in the memory.h file, then you must be using, it ends with like, well, it goes else is the last one you do in an F. And so then it tries to find the OV5642 camera. And then once it does, it says, okay, it's detected. You know, if it's never detected, it's just going to stay there and it's not going to get out. So it's just going to keep trying. And then, so once that's detected, it ends all that. So this is all one thing that's together. It seems like really long, but it's really just doing some simple thing. And then you could always add spaces just to know what's going on. We don't have to do this unless you want to. And then it starts using functions that are probably gotten from the arducam.h file. Oops, where are we at? Okay, and you know, it sets a format. It's going to be like, okay, these are JPEG images. If this camera is defined, we're going to set the resolution to this. If you want to change the resolution, you change it here. And then we're going to get into this a lot more. For now, I just wanted to tell you about the structure. So this is all things that just run once. Obviously, with the while one loop, you can force it to keep running until something's detected and then break away from it once it is. So these are just little strategies that, but in general, void setup, it's not going to go back up to void setup. It's just going to run once. And then once it gets to void loop, all it's going to do is constantly call on the myCamSaveToSD function, and then it's going to wait 5 seconds and do it again. If you remember from the example where we ran this example, what we did was we took a picture every 5 seconds and saved it to the SD file. And as you can see here, that's exactly what's going on. So this myCamSaveToSD function, this one up here, where is it? Oh yeah, this one. So here, this myCamSaveToSD file, this is all the steps it takes in order for you to take a picture. What's good is that you can copy basically most of this and then just use it really easily. But basically you take, you know, it runs all this code once in order to take a picture and save it into the SD card. And this function is called down here in the void loop. And then it waits 5 seconds and then it runs it again. It waits 5 seconds and then it runs it again. And it does this forever until you turn off the microcontroller. Now, of course, in your satellite, you're probably not gonna just take pictures every 5 seconds. You're gonna wait for a specific flag, like, oh, if this signal was detected, run this file, for example, you know, take the picture and save it to the SD card. And obviously there's a lot more that goes into this, but it's like awesome, and this stuff is very exciting. So I hope that that helps. What happens is that, so we tend to include files up here. Include files and other things. And then, so for now, let's just actually just ignore this. So you're going to include files and other things, whatever files you're going to reference. And then, you know, you can write any functions. And then you do your void setup. Oops. And then you do your void loop. And here you can obviously have like 1, 2, 3, 4, whatever, however many functions you want that you're going to use inside the void loop. And oops. And that's basically what you're looking for. So we did this here. We can do this for any other example. I just use this to separate what's going on. Let's do that somewhere else. So let's copy this line. Let's open another one like I don't know. Let's go to a low power mode example. So this is where it teaches you, or it does the code in order for you to have your camera in low power mode. So you're definitely going to use this concept in order to save as much power as possible with your camera in space. But okay, so as we can see, it's doing the same thing. It's including the files it's referencing. It's only using I2C and SPI, and then the arducam.h from the memory saver file. It's again figuring out what camera it's using. You know, it's doing that. And it actually doesn't use any, it looks like it's not making any more functions here. So it sets all that up here. And then it goes to the void setup. So let's see where this ends. Okay, so it ends here. Oops. And then it goes to the void loop. And it should stop there. Oof, okay. Okay. So it looks very long, but in reality, it's just constantly different situations. Like for example, let's see why is this so long? Why is the void loop so long? It's, okay. So what's going on is that, okay. So really quickly, if you guys look up switch case loops or functions, you're gonna see exactly how this works. So basically right here, temp, the word temp is defined, and then it's saying that whatever is typed, say like a command from ground, if you send a 0, okay, so say, okay, really quick. So this switch case function, it's basically a function where there's a bunch of different cases. It's kind of like an if-else loop, where if the case value, if temp is 0, if the case is 0, it's going to do all this. Otherwise, if the temp value is 1, if the case is like, that's going to be case 1, it's going to do all this. And again, if it's case 2, it's going to do this. And if it's case 3, it's going to do this. And if it's case 4, it's going to do this. If it's case 5, it's going to do this. So that's all this is kind of doing. It's basically waiting for an input. So serial.read is whenever you type something into the serial monitor, right now, whatever you type into the serial monitor is going to be registered by this temp. So say I press 0 and then enter, temp is going to be registered as 0. And this switch case is going to be like, okay, temp is the value 0. And then the case follows by the value of temp. And if it was 0, you know, it's going to run this. And it's kind of just checking for a bunch of different situations. And that's why it looks so long. But in reality, it's only going to use it's only going to use like this for this whole thing, you know, if we type in a 3. And it seems that that is, it's just setting the different resolutions. Again, I know it looks complicated. I don't want to focus too hard on it right now because this lecture would be very long, but that's what future lessons are for and what the live lessons are going to be for as well. So yeah. Alrighty, so there you go. You can see it just used the void loop. So it started by just including the files it's going to use, figuring out which camera we're using and setting that up. And then it does a setup of, basically it just wants us to run once as well. And then it gets into the void loop. And there's just a lot going on. So again, I'm sorry for not going over this right now, but in the future I am. It's just to keep this concise and conceptual. Okay? Feel free to ask me any questions whenever. I know this can be intimidating, overwhelming, and that's normal. And all you have to do is not give up and just keep going. You know, really play with this by yourself. Do a little simple, turn on an LED, start getting creative with other projects. There's many projects online. And then once you get to do all that, you're gonna just be like, oh, okay, I know what's going on. It's a lot easier. If you look at this for the first time, and it's just gonna be overwhelming and you're gonna be like, what? But don't worry, it's gonna be okay. We have some time and we're gonna practice a lot. So this is just generally how everything is set up. Again, I know there's a ton of code, but most of it is not even used sometimes. Like in this case, all these cases, out of all the cases defined, only one is used. And it does something very simple. It just sets the quality of your camera. So it's not that complicated, even though it looks complicated. And yep, that's code for you. But again, it's very rewarding and you're going to be able to do a lot more with this. So I hope this kind of helped. Whenever you look at examples, just make sure to separate everything by this. So every time there's files, be like, okay, I'm just going to separate everything. And then you can start looking internally into what's going on inside of these. And yeah, that's basically it, guys. All right, we're going to keep working on stuff and learning more. So just stay tuned for the next lessons, and we should be having a live lesson pretty soon to help everyone and just go through the codes. And hopefully you guys have the hardware now. I'm going to ask you guys soon if you do, because that's going to be really helpful. All right, guys, have a good day. Thank you guys for watching, and I'll see you next time. All right, bye, guys.